So we start by writing out, here I'll do it to start, our derivative f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all divided by h. So there's our definition of a derivative or Newton's quotient. We're going to use this and plug things in and use algebra skills in order to solve it. The problem is right now is when we plug things in, if we want to plug in 0 for h, right now we're dividing by 0. Anytime you're dividing by 0, that can't happen, so we can't solve it. What we need to do is come up with some way to stop us from dividing by 0, because then we'll be able to evaluate the limit. So we have to write the limit as h goes to 0. As far as terminology goes, we have to write this until we can actually apply the limit. So we still have this all over h. What is f of x plus h? That means we are replacing in our function wherever there was an x with an x plus h. So there was an x inside of our square root, so now we're going to write x plus h inside of our square root instead. Minus f of x is just 3 root x. Now at this point, with all of our other ones that we had up until now, right, you had things that you could square, you could combine like terms. There was mathematical operations that you could do. The radical one is different because at this point you look at this, I can't distribute the 3 inside unless I change it to a square root. But even if I did that, these square roots are not the same. I can't put them together. There's really no math that we can do to simplify this one. So with radicals, this is a place where a lot of people get stuck. Sort of the same way that when you did identities, you got stuck, right? Sometimes you got to a point where you got stuck in identities. Remember doing those trig identities last year? Where you're proving things, and sometimes you would get stuck? Now, one of the strategies that you used in identities when you got stuck is a strategy you can use in this one, now that we're stuck. And that strategy, should I tell you or should I let you ponder it for a bit? Should you want to look at the pandas in December and get frustrated by that instead? Strategy is we're going to multiply by something. We're going to multiply by 1, which doesn't change what something's equal to. You're always allowed to multiply by 1, but we're not just going to multiply by 1 and 1, because that's not going to help us very much, because we're going to get exactly what we started with. Okay? We're also not going to multiply by 2 over 2, even though that's equal to 1. We have to come up with a strategic value of 1 that's going to help us. Something that involves square roots. And what we're going to multiply the top by and the bottom by is exactly the same thing that was on the top with our square roots, but you notice that I have a plus sign in between. Does anybody remember what this is called compared to if you have a binomial with a minus sign and you write it with a plus sign, or vice versa? Do you remember the math word? It starts with con. It's not con artist. The conjugate. So sometimes these really obscure math words, these definitions that we learn temporarily and then forget them, if you learn them well, Then they become part of your mind that when you come to a new question, if you have a word like conjugate, then that strategy might appear for you to use. So we're going to find out with these square root equations that we're going to use the conjugate quite often. Because what does the conjugate do when we multiply? It gets rid of our square roots, right? When was the last time that you used a conjugate with square roots? Was in grade 11 when you had to rationalize the denominator. Remember these ones? Where you have root 3 plus root 7 on the bottom, and you had to rationalize the denominator? You had to multiply by the conjugate in order to do that. So that strategy that you first learned in grade 11 is coming back now. And if we multiply this out, whoa. On the bottom, I'm going to keep the h factored out because my goal is to get rid of that. That's what I want to cancel out. So I'm not going to multiply the bottom together. But when I multiply the tops together, I'm going to get 3 root x plus h times 3 root x plus h. That's going to just be 9x plus h. And the nice thing about a conjugate, when you multiply this set by this set and you do all of the arrows, can you see that when I multiply these two outside ones, that I'm going to get 9 and then root x plus h times root x? And when I multiply these two inside ones, I'm going to get negative 9 and then the root x and the root x plus h. Those are going to go away. So you end up with a difference of squares, and minus 3 times minus 3 will be minus 9, and root x times x will just be x. And something wonderful happens, because now we have some algebra that we can actually do on the top. Oops, no equal sign there. We get 9x plus 9h minus 9x and so the top just becomes 9h. And now we can simplify. The problem that we were having the entire time is we were dividing by 0 because of that h on the bottom. But now we can simplify that h away. And with that h gone, if you look at what's left, can I plug in 0 for h now and not have a problem? Yes. Because if I plug in 0 for h now, I'm just going to get 9 on the top, and I'm going to get 3 root x plus 3 root x on the bottom, which will become 9 over 6 root x, or 3 over 2 root x. So we can say in the end that our derivative is equal to 3 over 2 root x.